This is a volcano. Now you might be asking yourself, why am I learning about volcano? I think they're rather important because they create life, but they also destroy life. So it's important to learn about them. Now before we talk about volcanoes, we have to talk about where they come from. Now where they come from are plate boundaries. And all across the earth there are these plate boundaries, and they're all moving cohesively. And there are three different types of motion: divergent boundaries, transform boundaries, and convergent boundaries. What we have here is a convergent boundary. What this basically means is that these two pieces of crust are going against each other and colliding. And essentially, one has to submerge, and the one that is less dense submerges, causing the rock to heat up and the magma to rise, forming mountains. And these mountains are usually volcanic because of the convergent boundary. Next up, what we have here is we have divergent boundaries. Now, these boundaries act as if they are pulling apart from each other. And essentially, what this means is as these two pieces of rock pull apart from each other, the magma rises, creating mountains. And this is very common in places like the Mid Atlantic Ridge. And finally, we have transform boundaries. Now, these boundaries move side to side. They don't actually form any mountains, but they can cause things like earthquakes and are very common throughout the entire globe as well. And you can see them common in the Mid-Atlantic Ridge as they create these lines which kind of transform the boundary a little and move it to the side. Now that we learned where they come from, we can learn about the main types of volcanoes we will talk about, which would be shield volcanoes and stratovolcanoes. Here we have Mauna Loa, the shield volcano in Hawaii, and you can see those deep grooves on the side showing exactly where the lava is going to spill out, and it's going to do it slowly because it's a shield volcano, and that's why it's such a good tourist attraction for Hawaii, because the lava slowly spills out and it's not really dangerous. Now, shield volcanoes are usually the biggest because of how wide they are. They aren't really too tall, though, which is the reason why they're not really destructive, because they're not so tall, so it just slowly oozes out. And the thing is with shield volcanoes is that they're usually on divergent plates, which makes sense because convergent plates are usually the ones that have the stratovolcanoes. Here we have an example of the boundary and showing the shield volcano. There's the divergent boundary, and there's Iceland's shield volcano. This is Mount Fuji, the strato volcano in Japan, and you can clearly see it's different from those shield volcanoes because it protrudes up and it's much taller. And these play no games. Once they erupt, you gotta go because they're gonna blow a ton of ash and a ton of lava, and it's gonna be very dangerous. Now, stratovolcanoes are known to be very explosive, very dangerous. They're made mostly of andesite and basalt. They're created usually by an oceanic plate and a continental plate in convergent boundaries, which is what makes them so dangerous. Now, finally, we have the actual parts of a volcano. Firstly, we have dikes and sills. They are basically the same thing. They are both magma veins, but dikes are perpendicular while sills are more parallel and horizontal. And we can see this by looking at Engineer Mountain. And if you look at the sides here and zoom in, we can see quartz just horizontally across the sides there. And if we turn, we have more here. It looks more horizontal. And here we have possibly the most famous dike in the world, the Great Dike of Zimbabwe. You could see it stretches for miles perpendicular. It's igneous intrusion, really. And secondly, we have batholith and laccolith. They're both magma structures, but laccolith have a flat bottom, while batholith are a little more obtuse. And we can see that with Sebebe rock. I believe the largest batholith in the world, and you can see the steep incline walls, the irregular walls. That's how you can tell it's a batholith, and you can just tell from the top it's a igneous intrusion. And here we have a laccolith. You can tell from its clean dome shape and its flat bottom that it is a laccolith, and it is located in Montana. It is a Stillwater igneous intrusion complex. We still have one question, however. How does this turn into this? And the answer is quite simple, really. It's all magma. Magma builds up and it continues to build up. And once it becomes lighter than the surrounding rock, it rises. And once it rises to a certain point, it will overflow and it will erupt. And depending on the volcano, depends on how catastrophic the eruption will be.